Today we are back with our series discussion on how to solve two unknowns to equations, and today we are going to be reviewing another method called the comparison method. In this method, what we are going to do is basically we're going to start with our same set of equation that we have from last time, 2x plus y equals 8 and x minus 3y equals 4. So the idea here is that I will try to find x from this equation and also x plus from this equation. So when I find x or y, either of those variables, and then I'll try to equate these two unknowns. So the x from this equation should also be the x from this equation. So if I find these two in terms of their y value and equate them, I can find my answer for y. So let's start. I put this equation over here, and I will put this equation over here. So from our discussion on how to solve two unknowns to equations, I know that I have to rearrange this side, x and 3y, in a way that I have x on one side. So I have to take whatever unknown I have, which is in this case this guy, to this side to have only x on one side. The same thing applies to this equation. So let's do that. On the left side, I get my x equation directly. So I have x equals 4 plus 3y, which is exactly what I'm looking for. But here I don't really have x. I have 2x. So the next step is to divide both sides of this equation by 2. Remember, whatever we do from one side, we have to do it to the other side as well. So divide by 2 and divide by 2 over here, because I'm looking to find my x. Now, this step is very important. So what we are trying to do is find x only parametrically from both equations, from this guy and this guy. Now, if I do that step, I get x equals 4 minus y by 2, because 8 divided by 2 is 4 and y divided by 2 is y by 2. Okay, now I have all I need. All I have to do is to say this x equals this x, or basically this side of this x is equal to this side of this x. So if I'm equating these two, I can basically say that these two are also equal. So I'm going to do that. I'm going to put these two equal, and now I have reduced my two unknown to equation this to one unknown one equation. Remember, this is our strategy to solving two unknowns to equations, to reduce them to one unknown one equation, which are easy to solve. Okay, this equation does not seem very easy to solve. I have y by 2, which is not really fun to work with. So what I'm going to do this time is I'm going to multiply both sides of this equations, those two sides, by 2. And if I do that, I get 8 minus y from this side, because remember, this has to be distributed. We remember this from our discussion on one unknown one equation. So 2 times 4 is 8, and 2 times y by 2 is 2. The same thing here. I get 8 plus 6y. 6y. Okay, so I have 8 minus y equals 8 minus 6y. Now I have to rearrange stuff. I can take this x to this side, and this will become, because this is plus here, it will become minus 8, and this plus 8 and minus 8 cancel out. I will have 0. If I take this minus y here, it becomes plus y, and I will have 7y. So the equation becomes 7y equals 7, and if I divide both sides of this equation by 7, I get y equals 0. Okay, I have my y. The last step to do is to just put this y value into either of these equations. Any of these equations really will work, but I want to do it in this one because this easily and directly gives me x. If I do it in this one, it would give me 2x. Then I have to do some extra math. So I'm going to be smart and use this guy. So by putting this y equals 0 in this equation, I will get 3y. If I put y equals 0 in this, I get x equals 4 times 3y, or 4 plus 3 times 0, which is 0. I get x equals 4 plus 0, because x equals 4 times 3y, 4 plus 3y, and y is 0, and so is 3y. So I will get x equals 4. So y equals 0 and x equals 4 is my answer.